So let's continue our work in the preliminaries of completing the square. And in our last video, if you recall, we had a binomial. I'm looking here at number 5. We had a binomial like x squared plus 6x. And we did not have an extra term, but we filled in the constant term that would make x squared plus 6x plus this term a perfect square, right? Okay, so this time, the instructions for the problems are a little bit different. We have a trinomial to start, and the trinomial, it's not a perfect square, okay? But you're going to rewrite the trinomial in this special form. You're going to rewrite it as a binomial squared plus some number. Okay? So, here's what you're going to do. You're going to look at the first two terms, x squared plus 6x, and you're going to ignore the 164 for a minute. Okay? And you're going to look at the 6x, and that's going to be your b, right? And you're going to figure out what term is needed to complete the square with the x squared plus 6x. So in our notes, I went ahead and put in some fill in the blank little helpers here. So first of all, b is coefficient of x, which is 6. And again, this is b because a is 1, right? The leading coefficient is 1. So we're going to use b as 6, okay? And then we're going to take half of b. So half of b is 3. So half of 6 is 3. And then we're going to square that. So 3 squared is 9. So then we are going to complete the square, x squared plus 6x plus 9. That would give us a perfect square trinomial that factors as x plus 3 squared, right? And this is exactly what we did in the previous video. So if this is a little confusing, make sure you go back and look at that previous video first, okay? But this is the new piece. The original problem had this 164, right? This 164. So I'm going to leave the 164 there. And then we just completed the square over on the left and added an extra 9 that wasn't there before, right? So we can't change the problems by just adding a 9. We whatever we add to the problem, it has to equal 0 so that we don't change the actual problem the way it started. In other words, we need something equivalent. So what we're going to do is this little trick. Since we added a 9 here, we're going to subtract the 9 from the 164. Okay? So basically what we did is that we're taking 9 away from the 164, grouping it over here with the x squared plus 6x to make a perfect square. But then what's left over when we take those 9 the 9 away from 164? Well, that's 155. Okay, so now we have this in this form they wanted us to have it. Remember what it was? It was x plus number. They're calling it capital A, which is not the same as the small a in our standard form, okay? I don't want you to get confused because in math, case matters. And so this big A here is not this little a. It's not the leading coefficient. This is just some number, okay? So in our case, it's 3. And then plus another number b, which in our case will be 155. All right. Let's go to 6. So we were starting again. We're starting again here with a trinomial. Okay, but we're going to look at the first two terms and complete the square with the first two terms. So we're going to ignore the 72 for a minute. So here we have again a binomial with leading coefficient 1. So that negative 16 is going to be our b. And we're going to go ahead and take half of that, which is negative 8. And then we're going to square that, which is 64. Negative 8 times negative 8, 64. Okay, so we have x squared minus 16x plus 64. Okay, but here's the thing. We started out with 72, right? And we just took 64 from the 72, right? We used 64 of the units from the 72 with the binomial. So what's left here? If you say 8, you're right? Because these two, 64 plus 8, add up to 72. Okay, so see how this new polynomial that has 4 terms is equivalent to the original trinomial with 3 terms. And why did we do that? Why did we do that? So that we could factor, so that we could look at just these 3 terms, and that's our perfect squared trinomial, and we could factor it as x minus 8 squared. And then, what do we have left over? Oh, we had an extra 8 left over. See what I mean? Okay, let's go to the next one. X squared plus 12x plus 148. Okay. Again, same idea. We're going to look at the first 2 terms, and we're going to complete the square with the first 2 terms. So x squared plus 12x. This coefficient is 1. 12 is b. We're going to take half of b, which is 6, and we're going to square it, right? Which is going to be 36. So to complete the square with the x squared plus 12x, we need 36. What we have is 148, but we've now used 36 of the 148, 36 units of it with the binomial. So what's left over? Well, subtract. So 148 minus 36, subtract that so you know. So it's 112. Okay, so take the first trinomial, the first 3 terms, and factor that, which is x plus 6 squared. And then what's left over? A plus 112. Okay. Number 8. X squared minus 8x plus 46. We're going to look at the first 2 terms. X squared minus 8x. A is 1. Okay. So b is negative 8. B is negative 8. Take half of b. Half of b is negative 4. And then square, which is 16. So plus 16. So now we used up 16 of the units from the 46. So that means we have another 30 left over. You see how these two add up to the original 46? That's the part that might be confusing. Okay, and then look at this trinomial and factor it. That's x minus 4 squared, and then add to it the leftover 30. Okay. All right. Here's another couple of examples that are kind of similar. We're going to use the same idea that we used in the last 4 problems to put this quadratic function, because see how it now has the y and the x? So you've got a quadratic equation on the right hand side, and so you have y equals a quadratic, right? And we're going to put that in this special form, y equals x plus h squared plus k. If you think that looks a lot like our x plus big A squared plus b, then you're right. Okay? You're absolutely right. Okay. And again, just a reminder that this quadratic function, the graph is a parabola. Because that's going to be useful later in this chapter. Okay. So once again, look at the x squared plus 14x. B is 14. Half of b is 7. Square that and put it here is 49. Oh, this is the first time where our number that we added to make the perfect square is more than the original constant. The original constant was 48 and this one's 49, right? So what does that mean? That means when I subtract 48 minus 49, then I'm going to get a negative. That can happen. This is a negative. And then over here, just go ahead and factor that. Awesome. Awesome. Okay, and 10, same idea. Okay, same idea. Looking at those two terms. Half of negative 10 is negative 5. Squared is 25. But I only had 24 to start, so that means I need a minus 1, right? 25 minus 1 is 24. This is y. Y equals factor x minus 5 squared minus 1. What's going to be interesting later on when we work with parabolas, that is that this 5 and that negative 1, so this order pair that comes from this special form we were just working with, this is going to be the vertex of the parabola. So that means that lowest or highest point. Okay, but that's coming up. So you don't have to worry too much about that just yet, but that's coming up.